You have probably heard volume, variety, and velocity when it comes to big data. But let's try to ground that and put our arms around it. I'll start off by talking about volume, and in this case I'll talk about Facebook. Truly unprecedented numbers when it comes to our human history. Over 1.5 billion active users per day. Really surprising. Another number, in Europe alone, it's over 300 million. When it comes to photos, you have over 300 million photos per day. When it comes to comments, you have over 500,000 being made per minute. When it comes to status updates, that's over 300,000 per minute as well. So it's a tremendous amount of volume, but we also have variety. And I'll give you some numbers here per minute. When it comes to applications for jobs on LinkedIn, that's over 70,000 applications per minute. Over 500,000 tweets, over 100,000 Instagram posts, over 700,000 hours of video per minute. When it comes to WhatsApp, you have over 42 million messages being posted, again, per minute. Tremendous numbers and tremendous variety. You have other ones as well when it comes to YouTube, when it comes to emails, that on its own is over 200 million. So we have volume and we have variety. Now, when it comes to velocity, we can look forward here, and I'll give you some numbers around autonomous vehicles. And in this case, this is what is coming, and we already have some sense of that, what that could be. The cameras that are mounted on the vehicles that are used as part of the navigation are 100 megabytes per second. When it comes to LiDAR, the technology that is used to sense the world you're moving through, that's another 100 megabytes per second. Now, when it comes to entertainment, conservatively speaking, we can say 25 megabytes per second here. Now, there's many other sources of data like sonar, GPS, radar, and so on. However, once you sum all of these up, you have about 20 terabytes per day, 20,000 gigabytes. Going forward, that number will increase quite a bit. Every new generation of technology generates more data, and we're also hungry for it. So as you can see there, you have tremendous volume, variety, and velocity. And that provides for some interesting opportunities. When it comes to career, you certainly have the group that will need to analyze this data. You have another group that will need to process and move this data as well. Then you have the third group that will derive insights from it. All of this big data is the fuel that is needed for our engine of predictive modeling, the engines that will allow us to make predictions about the future, and really what has become essential in today's marketplace, an AI-enabled economy, and where we're using all of this information to make better decisions about our future and to minimize our risk while doing so. Everyone recognizes the value of big data. Everybody is rushing to try to develop the capabilities. You've even heard terms, no doubt, such as data is the new oil. However, just like oil, we need to be able to find it, to extract it, and to refine it. Now, when it comes to data, it can be a lot more fuzzy what we mean by establishing a data practice to be able to derive insights to lower our risk from our data. So I'll go here through grounding those concepts, and I'll start off by giving you 4 high-level points on this. What is data and what is establishing a data practice? We need to collect, we need to store, we need to process, and we need to consume this data. Now, when it comes to giving you those 4 bullet points, maybe you're getting a pretty clear mental picture. However, as we dive deeper into each of these, you'll see that it is not as clear as it might appear, and you can see then why it takes years for organizations to reach the level of maturity and capabilities to be able to do so. So we'll start off here with collections. Now, when it comes to collections, your data doesn't come neatly packaged in a way that you're ready to use it or store in this case. You have multiple sources of this data. Even when it comes to applications themselves, you have web applications, you have mobile applications, you have desktop applications. And given the modalities of these would come at different frequencies and different ways of packaging through different sources, different protocols, and so on. Then you have your logging and your monitoring. Any system that's up and running needs to have logging and monitoring in order for you to understand what's taking place. The granularity, the velocity of this is going to be different just as well. And then you have IoT. IoT really brings home the reality of data. We tend to think of data as these batches of information that we neatly connect, then we move on to a second stage where we process and derive data. But the reality is that data never stops. When it comes to sensors, they never stop sensing. So this data is continuously being generated. And so we have streams as opposed to nicely bundled type of packages, which means in general that you have volume, you have variety, and you have velocity that change through all of these collection mechanisms. Now, the next thing that comes is, how do you store all of this? Back in the 1970s, when relational database management systems presented themselves, everything was neatly modeled, the famous data modeling exercises that was done in enterprises, into these neat little tables that maintain in place or were maintained in place for decades many times. However, now the world is quickly changing, and there's a lot of data that doesn't really fit into a relational model. So you certainly have relational, and it's still the backbone of many enterprises today, but then you have non-relational. You have document storage databases that are a lot more flexible, that don't have schemas. Then you have much more agile databases like value pair databases, where you're really just creating a key and a value, even more friendly than creating variables in a programming environment. Then you have streaming databases. They are meeting the challenge of being able to continuously intake data from where the data is being generated and notify all of those that are interested in this oncoming stream of data that is occurring. In between all of this, we have cloud offerings, we have things that are distributed and decentralized, a truly great level of innovation when it comes to storage mechanisms. Now, as we go forward, we've talked about collection, we've talked about storage, we have extract, transform, and load. Once we have all of this, now we're tasked with the challenge of being able to integrate all of these separate data sources into something that we can use to process, to derive insights from. Now we have the big platforms, we have the big data engines, things such as Hadoop, things such as Spark. We have workflow mechanisms like Airflow that try to handle the complexity and the challenge that it is to bring all of these different pieces together and create pipelines. Once again, we have very different modalities when it comes to the speed and the granularity that we can work with this at. So the last column that I'll mention here is one of consumption. So you've collected, you've stored, you're extracted, transform, and load into your processing engines. And once you have done that, now you need to consume it. Now you could do so from many of your traditional applications, things such as Excel, Tableau, Looker, or you could create custom front ends, which many organizations do. But either way you do it, you can see here that there's a tremendous amount of complexity as you move through these 4 levels. There's also many different expertise and titles when it comes to an organization. You have your data analyst, you have your data engineer, you have your data scientist, you have your machine learning engineer, you have your data architects, and the titles go on. And a lot of what they're doing is they're illustrating that it is quite challenging to be able to have the level of expertise that would allow you to go end to end. And because of it, there's a lot more slices that are dedicated to different personnel. So this is the full challenge that organizations are faced with when it comes to developing a data practice, and the maturity that you need to have, the level of tiers that you need to move through when it comes to your expertise and your capabilities are also ones that will take years for you to master. So if you start now, many groups a couple years in are doing already pretty good, but as always, you need to have the processes in place, the technology in place, and also the people, meaning the talent. When it comes to building a data practice, something that can consume the big data that you're going to collect, there are 3 roles you should think of. The very first one is your data engineer. This is the one that's going to collect, it's going to store, and it's going to start to process that data. Next up from that, you have your analyst. This is going to collect that data, it's going to refine it, it's going to do transformation, it's going to ask some questions of this data. So that is your data analyst. Now, the third title that you will see is that of data scientist, once the data has been collected, has been aggregated, has been transformed, has been refined, a lot of the low-hanging fruit data type of analysis has been done, this is where your data scientists can do predictive modeling. Now, something that perhaps is not too obvious, and we can blame here Harvard Business Review's article that was published that said data science is the sexiest new job. You can see here that the data scientist can only perform its work after your data engineer and your data analyst. Your pure data scientist doesn't have the skills to be able to do that. And so when organizations are first starting out, the first hire that they should do is your data engineer. The data engineer has a great deal of range, and many of them can extend well into the analyst, and some of them even into the data scientist. Now, once you have that firmly in place, and that usually takes about a couple of years, then you can move on to your data scientist. Many data scientists that I know in industry that have been hired to do data science have begun by spending the first 2 years really doing data engineering. Now, if you can hire a data scientist that can span that spectrum, that's a fantastic thing to have. However, most of the industry does not have that level of expertise. So one of the takeaways from this message here is that you shouldn't hire your data scientist until you have built the base of that pyramid. You have done your collections, your movement, your transformations, your analysis, and then once you have that clean data, then you can hire your data scientist. Now, there's some other titles that you might hear as well, such as machine learning engineer and data architect. Your machine learning engineer often extends beyond the data scientist. And what I mean by that is that your pure data scientist really doesn't have the software engineering capabilities to be able to productize a predictive model. So often you'll have a machine learning engineer that can pick up that model from the data scientist, polish it, extend it, productize it, and then extend all the way into something that is closer to being deployed. Typically, they will then work with the data engineer to be able to do that. Now, you'll often hear as well of a data architect. In all of the titles that I mentioned before, you can envision this title as someone overseeing the entire stack. So there you have it. These are the titles that you can think of when you're thinking about taking your big data and translating that into value for your organization. When you think of big data or you think of data, perhaps the first thing that comes to mind is a relational database management system, perhaps just a database. And for most enterprises, that means a relational database. And this is technology that comes from the 1970s. And because of it, has a lot of limitations for our needs today. In those days, the generation of data, the updates to the data model, the updates to the tables that you were storing that information into was quite rare or quite slow. In the days of the web, talking about the mid-90s as opposed to the mid-70s from where relational databases come from, our needs increased. We had more variety, more velocity, bigger volumes of data. And so we needed different types of storage mechanisms. And you see the market responding to this. And that evolution of products has continued all the way until the present. One of the first ones that we got was the document database. This was a database that happily took anything you gave it. It didn't matter if it was unstructured, didn't matter if you had video mixed in with audio, mixed in with text, mixed in with geospatial data. It would take your mess and you could easily recall it. This turned out to be one of the fastest growing databases at the time, which still continues until today. Then you had databases that really offered a great deal of simplicity, like key value data pairs. These were databases that would allow you to store anything as simple as a key and a value, and into that value you could put more sophistication if you needed. It allowed you to get going right away without all of the crazy overhead that a relational database management system imposes on you. Now, as we scaled up past the web into the 2000s, we had really walls that we were hitting given the capacity of databases. And into this vacuum stepped in platforms such as Hadoop that could horizontally scale with commodity servers. This was a great addition. A generation of companies used this technology to be able to address and derive insights from their data and be able to store it in large quantities. So this was, again, very different than what we had in the past, responding to that big data, to that variety, to that velocity, to that volume that we had. And there were a great deal of innovation, as I mentioned, many other types of databases that have presented themselves. And the last one here that I'll mention, just because it is so different, is the databases that are now being offered in the cloud. And one of the characteristics of a percentage of them is that these databases are being offered to you without you knowing the implementation that is behind that technology. They're simply agreeing to meet with you a certain level of service, an SLA, a service level agreement. That is, you will, or I will take from you, meaning the database vendor, as much data as you want, and I agree to be able to serve it back up at a certain level of performance. In certain scenarios, this is exactly what you want. You do not want to run a server, you do not want to maintain an operating system, you do not want to pay a database administrator, you simply want the function of a database and let somebody else worry about scaling it up, about what it's running on, how it's going to perform. And for the cloud providers, they are looking at hundreds of millions in many cases, or at least at millions of use cases, and they are improving that technology and they're getting very good at it. And so this is a last edition that, depending on what you're doing on, could be a really great fit. Why do we care about data? This is a great question to always ask. What's all the big deal about this data? Well, it turns out that it takes us quite a bit to be able to learn something, to be able to derive information from it. If you think about the amount of time that transcurred between Aristotle and Galileo, it's about 2,000 years, but we're getting much faster. By the 1900s, our information was doubling every 100 years. By the 1950s, it was every 50 years or so. Today, it is doubling about every year. Really surprising the volume that we're generating data at. And it is projected that within the next 5 years, it will double at approximately every 12 hours. So we have an onslaught of data that is coming towards us. However, think about the following. About 90% of the data produced that we have today has been generated in the last 2 years. And it makes sense given the acceleration in the data that I just described. However, we're only utilizing about 1% of that. And if we think about organizations, you can see here why that is. Our organization's ability to leverage that information is growing linearly. However, when it comes to the data itself, it is growing exponentially. And so that disparity, that gap, is the threat. Are we understanding our world as well as we can? But it's also the opportunity to be able to derive insights. And this is a great opportunity when it comes to big data, to be able to harness the power of information, to be able to lower our risk by understanding our world better, to be able to better prepare for a future by understanding the patterns that are taking place. So as you can see here, the world is flooding with data. We have volume, we have variety, and we have velocity. We're generating currently at about 2.5 quintillion bytes per day, a tremendously, horrendously big number. However, we now have the computational capacity and we have the storage mechanisms. That is, we have the fuel and we have the engine, and we're getting better at constructing predictive models. So this is a great resource and a great opportunity. However, we have to improve and we have to become better at building data practices so that we can make use of that information.